So,
Say cap.
put cap on the video.
No.
Oh, because it is. It's on there now a couple of times.
Say cap.
It's on there again. 3 times.
We don't do any homework. We should do that. I swear.
So, couple of things about this week. First and foremost, this is the last week of the first quarter.
Yeah.
Now, for some of you, that means absolutely nothing. For others of you, especially if you are planning on going out for a winter sport or activity, that means a lot, because you have to have a passing grade at the quarter in order to be eligible to participate in that activity or club or sport. So, kind of a big deal.
Yeah.
Other big deal is these grades then go home. So if you have anything that you need to turn in, you should turn those in. Turn those in. There it is. This week, because you want to get those in and get those on the grades so that the grade that I have to put then on that report is as accurate as can be. Okay? So there's that. This one. Then, so this week, today we're going to be doing C7. Now, for you eagle-eyed students that are looking in your note packet, there's no C7 in your note packet. Okay? So we got something going on for today, which we'll be fine with. And then tomorrow we'll do C8, which will be adding and subtracting of expressions, but we'll go a little bit more in depth. Wednesday we're going to have a formative. Thursday then we'll do some more distributing with combining like terms and all of that fun stuff. And then on Friday, we'll start reviewing for your test. So we'll review Friday and Monday and Tuesday, which is kind of how it felt. Mrs. Hill and I just decided, yeah, we had talked about maybe even starting Unit D on Tuesday, but I'm like, no, let's not do that. We'll start Unit D on Thursday. Okay? So yeah, so there we go. Okay. So for today, your note page for today is actually your homework for today. Okay? Now, what I need you to promise me is that you pump the brakes. Okay? Because we're not going to start with number 1. Okay? Right? We're going to do 5 problems out of your 22 problems, and then when we're done, we're going to, then you can go start back at number 1 and work your way through it. Okay?
Why are we doing it like that?
What?
Why are we doing it like that?
Because it's something different, you know?
Well, one's first.
What?
One's first.
Yeah, I know, but I don't want to do number 1.
First and last.
Yeah, exactly. Ricky Bobby Inc.
Yeah, I got that.
Trademark, Ricky Bobby Inc.
I'll wear that shirt tomorrow. No. You didn't call? Hold on. I'm trying to think about that. Hey, what up? Think about it. They're gonna make you a shirt.
All right, here we go. So, we kind of broke up the front side of the worksheet into two different parts. So we've got the top 8, and then we got the bottom 4. Okay. So with that being said, okay. So let's do number 4 together. We'll start with number 4. Okay. Now, 2 things. 1, you got to show work. Okay. No cap. You got to show work. Swear. Okay. 2, we're gonna put answers where? On the line in the answer blank to make it easier on your old-eyed teacher up here who doesn't want to have to go searching through 18, different things of work. Okay? Right. So let's start with number 4. Okay? So if we have to show work, because we just said that we did have to show the work, then the minimum work that we're going to show is that we've got to take this, whatever's out in front, and we've got to multiply it in to all of those terms. Okay? All right? All right? So if that's the case, what is -2 times 3a? -6a, right? Because -2 times +3 is -6 times a is -6a. Okay. What? You're banging your pencil on your desk. It's kind of annoying. Yeah. Okay. What is -2 times -6b? Positive 12b squared, or just positive 12b? Then you said squared.
I said square.
Oh, squared. It sounded like you said squared, because that would be like b squared.
Square.
Okay? So -2 times -6 is positive 12, times b is positive 12b. Then we got to multiply it by positive 5. What's -2 times positive 5? -10, right? So because it's a negative times a positive. Okay. So there's our distributing, right? Now that we've got it distributed, now we got to ask ourselves, do any of those terms combine? Why not? Why? So that's okay. So one condition is the variables have to be the same, right? Okay. And what? What about the 10? So none of the variables are the same. That's just a constant then, right? Okay. What's the second condition in like terms? The variables have to be the same, so the letter has to be the same, and the nope. What's the second condition? The variable has to be the same. Look back in your notes. You all have your notes, even though we're not taking it in our notes today. What's the second condition? Variable has to be the same, and what else has to be the same? We're trying to define what makes it be a like term. Yeah.
Exponent?
The what? Thanks, Will. The exponent's got to be the same. Okay? So first condition is the variable has to be the same. Second condition is exponents have to be the same. If either one of those is not true or is a no, then they're not like terms. Okay? So the variables in those three are not the same, so they can't combine. What was that? Didn't we already? right? Because what is standard form? Biggest exponent, right? First, and then after that it's alphabetical, right? Okay? So we get that as our answer. Yes?
You should like throw away 6. 6 is
That's what we're going to do together. No, we're going to do it together. Point. Big text. Okay? So let's do 6 now. What's the difference between 6 and 4?
That's a fraction. Fraction.
But what's the difference? Yeah, the two that we're doing. We're doing 4 and we just did 4. And now we're going to start 6. And I'm asking, what's the difference between the two problems? And side note, it's a trick question. Because there isn't any difference between the two. Okay? There is 0 difference between those two problems. So what we did up top there in number 4 is we multiplied the term out in front.
How is there no difference?
Because watch. Because you got to take this term out in front, and it's got to get multiplied in there, and it's got to get multiplied in there. Right? So there's no difference between these. The difference is the term out in front now is a fraction. Okay? But the process is still the same. Okay? So, might have to show a little more work on these problems. Okay? So we've got 1/5 x times 15x. Well, if I rewrite that and I put my numbers next to one another, I could write this as 1/5 times 15 over 1 times x times x. Okay? 1/5 times 15 over 1. What does that, right here, this part right there, what does that equal? How did you get 3? Is, okay? Okay, so you got 15 over 5, and then you divide both top and bottom by 5, right? Because 5 goes into 15 3 times. Okay? So that part makes 3. Okay? What about the x times x? Nope, we're still not done with this first one. X times x. X squared, because there's 2 of them. If x times x, that would just mean there would be 1x. But there's 2 of them there, so it's x squared. Okay? Now we go on to this next part. Same thing. We've got 1/5 x, but now we have to multiply that by -20. Okay? So once again, we can put our numbers next to one another. (1/5) times -20. You got a 4.5-day break. You don't need any more. Okay. 1/5 times -20. -4, because you got -20 times 1 on the top. So this becomes -20 on the top over 5, which reduces to -4. Yep. Times x. So what's -4 times x? -4x. Okay. So can I combine my two final terms are right here? Can I combine them? Why not? So in this particular case, the first condition, we have the same variable. But the second condition, that the exponents are the same, is not. Okay? So this one would just be 3x squared minus 4x. Okay? All right. So now let's go down to the bottom. Like terms. Okay? Let's do number 9 together because it's an easier type 1. Okay? Any like terms. Well, first off, before we even start that, how many like terms do we have? Or how many, how many terms do we have? You know the rules? I don't care. How many terms do we have? We have 4 terms. Okay? Any of them like terms? Which ones? I like 7x. Negative 3x. Okay, so let's group those two together. So these two right here are like terms. Love it. Any other like terms? Constants are always like each other, right? Okay? So then those two are also like. And remember, the sign in front comes along with it. Okay? All right? 7, let's go with pieces of paper, and I take 3 pieces of paper away. How many pieces of paper do you have? You have 4 left, right? Okay? All right? 2 cookies, and your friend takes 2 cookies away from you. You got 0 cookies left, right? So should we write plus 0? Nope, shouldn't write plus 0. Side note, I forgot to mention it on the fraction one. I have been noticing a lot of writing fractions like over 1. Like, oops, changed over on me. Like that. Do we ever write that? This right here. No, we don't write that. Okay? So if I see that, just so you know, I'm going to mark that wrong. Okay? Because we just write 7 there. We're going to write it over 1. Okay? Same with under 0. So if we've got 0 on top and some number on the bottom, we just write that as 0. Because 0 divided by any number is 0. Okay? So we got that. We're good there. All right. Let's do number 12 now. Okay? So, number 12. How many total terms do we have? 5 total terms. Okay? So, I see a term right there, right? Because, Dom, you said we want to write with the biggest exponent to term first, right? We call that standard form. Yep, exactly. Okay. I see a term right here. I see a term right here. And I see a term right there. All that have x's, right? So all of those are like terms. Then I see this term right here. Okay? Now, if you're a crosser outer instead of a circler, or if you're a dot, okay, those all work. So by crossing out, I mean like you could say, all right, well, I use this one. I use this one. I use that one. Or a dot would say, yep, I used that one. You put a dot above the term saying that you got it in your next line written down there. Okay? Now, I'm a dasher outer because I still like to see what was there at the start. Okay? everything combined with the blue 2x squared? Nope, because that's by itself, right? So that's going to stay 2x squared. What about these green numbers in there? How am I going to combine them? Because they're all x's. You want to pay attention. You're not, because you got this one wrong. Yeah. So how am I going to combine those green terms? I got 1/3 of an x, then I got to take away 1/6 of an x, then I got to take away 1x. What do I got to have in order to combine those? What do you say? Got to have a common denominator. So let's rewrite this 1x here as 1/1x. Now, what's the common denominator between 3, 6, and 1? 6 is the common denominator. Yep. Okay. First one. What times 3 gets me 6? What was that, Will? 2. So I got to multiply by 2 there. So I got to multiply on top by 2. 2 times 1 is 2. Second one. Do I have to adjust it at all? Nope, it's already in the 6th. Third one. Do I have to adjust it? What times 1 gets me 6? 6. I'm going to multiply by 6 on top. 6 times 1 is 6. Okay? So now I've got them all in common denominator form. What do I do now? Yeah? Add or subtract what? Numerator, all the tops, right? Add or subtract all the top. What about bottom? Keep it the same. Okay? So we've got 2 minus 1. 2 minus 1 is 1 minus 6. -5. So the top here becomes -5. The bottom we said was 6. And we're going to have x there because that was x's that we were dealing with. Okay? You had 1/3 of a pie, and I wasn't very hungry, so I only took 1/6 of the pie. But then Jake got really hungry, and he took a whole pie, and we're down 5/6 of a pie. Yeah. Okay. All right. So then, now this, because it's negative, what's this sign going to be in between those two terms? What's the mathematical operation? Add, subtract, multiply, or divide. It's going to be subtract because we would be adding a negative. So we're just going to move that negative sign out to the in front. And then we got -3. Okay? Any of those terms combined. Why not? They all don't have the same variable. 2 of the 3 of them have x's, but they're not the same, or not the same exponent. And the 3 doesn't even have an x, so it violates all of our conditions. Okay? You now have the rest of the time to finish this worksheet. Okay? Any of your other worksheets that you may have fixed or gotten back today, or is on the grade report that I just handed out to you. Okay? So you've got plenty of things that you can be doing for the next